Okay, welcome everybody to practice test 22, speed run today. I've just realised I started recording this and the mic was off, so I've done the first 6 questions without audio. I've already written stuff down, so rather than do it all again, I'm just going to talk you through it, and that will let me focus on the more difficult ones. So, number 1, the mean is 12. Basically, the total of all the 5 cards is 60. Do 12 fives, take away the numbers you know. Whatever's left at the end is your answer, 17. Good. Number 2, right as an ordinary number. Just move the decimal point 6 places to the right. That gives you 8,800,000. Which of the cities has the least population? Look for the powers of 6, which is the smallest power of 10. And obviously after that, look at the first number. It is Barcelona, or as they say in Spain, Barcelona. What's the difference? Take the numbers away. You get 2.93 times 10 to the 7. But it does want you to round it to 2SF, so it's 2.9. Job so good. And number 3, solve. Multiply your fraction across. So multiply the 10 over to the left, giving you 10p equals 3p minus 5. Take away 3p from both sides. Divide by 7. Minus 5 over 7 is your answer. Number 4, easy peasy lemon squeezy. Just break the tree down. Again, you didn't have to break it down the same way I did, but you should get all the same numbers in circles at the very bottom. Right, I would always recommend before you deal with powers, because this question does specifically ask for powers, write that full, right? So it does say powers here, but write them in full first, then do the power second, because if you make a mistake on the power section, you probably will still walk away with most, if not all, marks. Number 5, right, get your percentage first. Every year it goes down 15%, so you multiply 0.85. Because that's 4 times, you raise it to the 4th power. Type that in your calculator, you get this. Bang. I did round it, by the way, I did round it to the nearest whole pound, because that's what it wants. Number 6, reverse percentages. So some number got multiplied by 1.12 because it already happened. Some number got increased by 12%, which gave an answer of £18.20. Meaning you got divided by 1.12, £16.25. Right, number 7, right, start by looking at this triangle here, Pythagoras theorem. So to work out x, which I'll call that side, you are going to do 7.5 squared, take away 6 squared, and you square root that answer. This is for not the area, but the height x. Maybe I shouldn't be shading that in blue just yet. But yeah, look, let's do that, right? So what's the square root of 7.5 squared? Take away 6 squared. 9 over 2 or 4.5. Cool. So you got your first length, 4.5 is here. So let's work out that area, right? The area, which I'll label in purple, is a half of 4.5 times 6, 27 halves or 13.5. Okay, meaning the total area of the triangle ABC, my bad, DCA, that's this one here, will be that, the total, take away 13.5, the area of the purple triangle, right? So let's take these away. 31.5, take away 13.5. 18 is the area. So to work out that length, the one that the question is asking us about, which I'll label AD, I'm going to call it Y. So remember, it's an area question, isn't it? So half of Y times 7.5 equals 18. Okay, so multiply by 2, divide by 7.5. You get 4.8. Nice. Right, question number 8. This we've got a cylinder and we're told the mass. Now for this question, you do need to know the formula for density. Density is mass over volume, so let me write that down first. Density is mass over volume. So what do we know? Well, we know the mass, but we don't know the volume. So let's work that out. Right, this is a cylinder. The formula for the volume of a cylinder, because it's a prism, any prism, you do the area of the cross-section. In this case, it's the circle, so pi r squared, multiplied by the length across here, which is h. So in this case, radius is 9 because it's half of 18, and height being 3.5, right? So that will give you your volume. So density is basically going to be mass 7.04 kilos over. Oh, be careful here. It does want you to, the units of density being grams. So don't divide by 7.04, divide by 7,040 grams. And this is going to be divided by whatever that is. So I'm going to just leave it as pi multiplied by 9 squared times 3.5. Okay, so in my calculator, these numbers go. And I'm getting 7.9. Or 7.9044 dot dot dot, which to 2SF is going to be 7.9. Okay, moving on, number 9. We've got 4 semicircles with a square in the middle. We know the area of the square is 36. Right, so this square, 36. Now, if we square root that, that'll be the length of each side, which will be 6. Now, you can think of this as 2 circles put together. So think of that as a circle with diameter 6. And this circle here would be identical to the purple one. Okay, so you only really have to work out the area once. So the area of this circle, pi r squared, be careful, radius here is 3, because you have to halve the diameter, would be 9 pi, right? So the area of the whole circle is pi r squared, pi times 3 squared, 9 pi. And there's two of these circles, right, if you think about it that way. So the total area will be your 9 pi plus the other 9 pi, which is the blue sort of 2 semicircles combined, plus, don't forget, your 36, which is the area of the square. Add all of those up to one decimal place. I mean, you can simplify to 18 pi if you want, plus 36, which will give you to 1dp 92.5. Just go double check with the mark scheme here, but I'm feeling pretty confident. Yes, it is correct. Number 10. Okay, PAF. So the angle PAF. Now, this is a hexagon, regular hexagon. You can use the formula n minus 2 times 180 to work out what all the angles in a hexagon add up to. So in this case, it would be 4 lots of 180, which is $720. But because obviously there's 6 of them, we divide that by 6. So that means that each of your hexagon's angles are going to be 120, right, for all of them. Okay. And we know that the length of each, we know that AB is 5, BP is 2. So what I want to know now is what is the angle of this, I'm going to call it X. Right, that's a right angle triangle. So what I'm going to use is SOHCAHTOA, because that's the opposite, and that's the adjacent. I'm going to use tan. So tan X is going to be 2/5. Always observe adjacent, do the inverse, and that will tell me the angle X, which is 21.8 degrees. I have rounded that number. So let's wrap this up now. Angle PAF is going to be all of this, which we said was 120. But that obviously includes the blue section we don't want. But we're going to have to take away angle X. So take away 21.8 from 120. I have rounded it again. So I'm getting 98.1985. I'm using the stored version of this number, which is slightly longer. But Yeah, because I don't want any rounding errors. So to 307 would be 98.2. You would get 98.2 even if you use the earlier rounded number. Degrees. Cool. Right, so we're now on number 11. The HCF, right, well, let's do a Venn diagram. So in P and Q, all the numbers that are common, put in P. So they'll have two, think of this as 3 times 3 times 3. So the 3 squared cancels out 2 of the 3's above. So you could write 2 3's there to represent that. However, P will have an extra sort of 3 in it. Likewise for the 5's. So they both share a 5, but Q has an extra 1. Oh, no, sorry, P has an extra 1 as well. And as far as 7 is concerned, you've got a 7 in common, but Q has an extra 7. So HCF is all the numbers in the middle. So HCF is all of these. 3 times 3 times 7 times 5, which is 315 is the HCF. Now, they are the same exact numbers for part B. This one wants P cubed times Q in the form. Basically, they want this number cubed. So you've got all of this cubed times just Q here. Nothing done with it, just Q. 3 squared. Okay. So when you cube it, you usually times all the powers by the number on the outside. So that initial 3 will be 3 to the 9, 5 to the 6, and 7, treat it as 7 to the 1, is going to be 7 cubed. And we still have to multiply that by 3 squared, 5, and 7 squared. I'm going to give that 5 there a power of 1. So when you multiply powers, remember you add them. So here, to wrap things up, we do 9 plus 2, 3 to the 11. We're going to do 5, 6, and 5, 1. That's times 5 to the 7. And your 3 and your 2 for the 7s become 7 to the power of 5. So this is your answer. 3 to the 11, 5 to the 7, 7 to the 5. Just going to confirm that here with my answers, which is spot on. Right, question 12. The language department has 108 students. Each student studies only one subject from the 4 subjects. 15 study French, 45% study German. Express the percent. Okay. Okay. So, what my initial instinct is, these sort of questions are usually two-way tables, but this is only about subjects. There is no sort of second thing. We're just measuring what language they study. And okay, right, let's just jump in. Right, so we know, first of all, so we know French already, 15. That's good to know. And we know 45% people study German. So F, I'm going to write, is 15 students. Be careful, German. 45% of 180. So do 180 divided by 100. That'll give you 1%, and then times it by 45. And then that will give you the total number of German students. So type it into my calculator very, very quickly. It gives me 81 students study German. So think of it, the Italian or Spanish is going to be 180. Take away these two numbers, take away your French speakers and your German speakers. So if I do 180, take away 15 and take away 81, I get, there's 84 students. Now the question does ask you to express it as a percentage. So to turn any sort of number into percentage, you take the number, in this case 84, divide it by the total, which in this case is 180, and you times that answer by 100. So doing all of this, I'm getting 46.6 recurring percent. Express the percentage of students in 10. Ah, okay, right. Okay, so the that would be if it was a percentage of the total. Now I've realised something. I probably would lose marks here, so let's cross that out. Let me reread. This is why it's so important to reread questions at the end. It doesn't say find the percentage of students studying Italian or Spanish. It says find the percentage of students studying Italian or Spanish as the percentage of those studying French or English. So instead of dividing it by 180, you're dividing it by the French and German speakers, which is 81 plus 15. So that would be what, 96. So we're doing 84, the Italian or Spanish, divided by the German and French, 96, and times that by 100. This was this is not usually how these questions are written, but you've got to read the question carefully. In this case, it's 87.5%. Okay. Number 13. Looks like a circle theorems question to me. Doesn't ask you for reasons, which is a little bit nice on our end. That's the hard part. Okay. Now we are told PQ these all points in a circle. PS is the diameter. Okay, so this is a semicircle. So PRS automatically must be 90 degrees. I don't have to give reasons because it doesn't ask for it, but for the sake of your revision for this coming exam series, if I were asked for my reasons, I would have said angles subtended by semicircle, or you can use the word diameter, are 90 degrees. All right, so we can start by drawing a little square there to represent the 90, or you could just write 90, either way is fine. PQR is given to you, and what are we doing now? It wants RPS. Okay, so look, we now have, if you look here, even though it's sort of within a semicircle, this is still a cyclic quadrilateral. So we can then say the angle PSR is 180, take away 136, right? Because opposite angles in a cyclic quadrilateral add to 180, so that's got to be 44. So you can add a 44 here. So, and the reason, again, is opposite angles, pardon my handwriting, in a cyclic quadrilateral add to 180 degrees. Cool. So we're almost done now, really, aren't we? RPS, which is the sort of angle in this triangle here. RPS. Again, you can draw the sort of triangle here. It doesn't need to be in a circle anymore, but one's going to be 44, one's 90. So RPS is 180, take away both 44 and 90. So I'm getting 46 degrees. And the reason, I know you're not asking this question, so you probably wouldn't pick any bonus marks up, but angles in a triangle add to 180 degrees. The reason I'm giving reasons is more often than not, they do ask for reasons. So we're a bit lucky in this paper, but for the sake of most exam papers that would happen, you'd almost always be asked for reasons. That was a bit of an anomaly, this one. Number 14, we've got a sector here. Center row angle 67, fair enough. The perimeter of the sector. So think of sector as, well, if I had the whole circle, what would help me work out this curved bit first? Well, if only I knew what the circumference is, I could just say, well, this sector is 67 degrees out of a total of 360. You could sort of imagine that you don't have the whole circumference, you've got a fraction that is basically 67 out of 360 of the circumference of the circle. So I know that you're expected to know circumference is pi times d. You also should know the sister formula, which is 2 pi r, because the diameter is the same as two radii stacked next to each other. This one's going to be more useful, obviously, because the sector is the radius, but whatever. If you double 5.2, you're going to get the same thing. Not a big deal. So arc length. I know a lot of textbooks sort of focus on the formula, but I always say, well, look, is 67 out of 360 of your circumference, which would be 2 pi r. So 2 pi, at this point now I can replace r with 5.2. So let's type away. That that expression is going to give me this purple bit here, the curved part of the arc. So let's type away 67 over 360 multiplied by 2 times pi shift pi times 5.2. It's giving me a nasty one, but it's 871 pi over 450. Calculator likes it as an improper, but look, it wants the perimeter. So remember, perimeter also includes the 5.2 here and the 5.2 up here. So let's add perimeter. Look, let's wrap it up. You've got your 5.2, your 5.2 plus this 871 pi. That's the one there over 450. Let's add away. And I'm going to round it to what, 3SF. So anytime you're asked to round it, because you know what, on a bad day you might do something really, really silly and round wrong. Happens to all of us. Always nice to just write your full calculator display out first is good exam technique. And then underneath you can round it. So always do that, right? Because if you mess up with the rounding, you'll only drop 1 mark. But if you type or write the wrong answer rounded and that's it, you might lose everything or more marks than you need to. So this one's 16.5 centimeters, its length, its perimeter. So I'm pretty confident of this. Let me just double check my mark scheme in front of me. And yeah, 16.5, VAR check complete. Number 15, we've got Alberto, Bill, Candela, Diana. I like these questions. At Excel, they like to always call them A, B, C, D, just because it makes our lives easier. Okay, so we got 4 people's height. Don't take it as a given that they're in ascending or descending order, but obviously we've got 4 people to think about. So let's just write 4 sort of blank spaces. To help me, I'm going to put the smallest on the left, biggest on the right, and obviously the 2 middle numbers from smallest to biggest, and the middle left and middle right. Okay. So Alberto's 158, Bill's 175, Candela's height is greater than Diana. The mean height, the range of these is 21. So what I'm trying to wrap my brain of is Alberto the shortest, or could it be Diana? I don't know. So if it was let's think range-wise. So range 21. I mean, let's presume Bill is the tallest. If I took away 21, I would get 154, which is shorter than Alberto, which would make sort of Candela. Okay. So it could be that let's presume this could be Candela's height. The reason I'm hesitating is what if Bill is not the tallest, but actually Alberto is the shortest? So Alberto shortest. Obviously that would mean that we would have to add 158 to 21. So the max height would be 179. So 158 plus 21. I mean, I've got the luxury of writing on digital paper, so you know what? Let's see what happens, right? Let's say Alberto is the shortest. So let's go with Alberto 158. We're making the tallest person 179. Obviously, the tallest person in that case would be Candela's height is greater than Diana's height. Candela's height is greater than Diana's height. So this obviously has to be Candela. Now, Bill won't be able to be here because if Bill was on that value on the middle left, the median would not be. It would not be possible to have 160 as your median, would it? So we'll put Bill here. Bill's 175. Now, this means Diana, in order for this to be the median to be 160, that has to be halfway between 175 and some other number. So if for 160 to 175, that's 15 going up, the other one has to be 15 going down. That would make this would have to be 145 for it to work. But we've now got a bit of a contradiction. The contradiction being, well, this isn't the smallest. So it kind of breaks apart. I think me sort of thinking that potentially Alberto being the smallest was wrong. The truth is actually, Alberto is probably the second shortest, making Bill be the tallest. Alberto, we know, is 158. And obviously Candela would have to be 154. Okay, this works now. Now, obviously, the median is 160. So if Alberto is 2 below, Denise has to be 2 above. So Denise is 162. And yeah, this works, right? We've got the correct range. 175 take away 154 is 21. We've got Alberto. Well, there's not really any restrictions on Alberto, but the median is 160. And Denise is bigger than Candela. Oh my word. Sorry, I got this the wrong way around, people. It says Candela's height is greater than Diana. Candela. So I got my names mixed up. So Candela is the taller of the two women, and Diana's clearly the shortest. So yeah, Candela 162, Diana 154. Double check the mark scheme. I'm pretty confident because I did check my answers and I spotted the mistake with my naming. Candela 162, Diana 154, mark scheme agrees. Sometimes you just got to, I know that my initial guess was wrong. Sometimes these questions are an element of kind of having your head two correct paths, following one, stopping when you hit a bump and trying the other one. That's part of the mathematical process. All right, we've got a kite here now. Kites, okay, A, B, B, C, and angle there. The area of the kite, right. So, a kite has opposite angles are equal. Where you've got the two equal lengths, the sixes, and your two equal lengths 11. Where the angle between the two different lengths are equal. So where 6 and 11 meet on both sides, and this is a characteristic of kites, is 118. Now, what I'm going to do is a lot of these quadrilateral, whenever you're asked to find an area of a funky looking quadrilateral, obviously if you've got, some have got formulas and rules that you probably studied well, like I'm thinking squares, rectangles, trapeziums, parallelograms. Fair enough. They've got some really, really easy formulas, but kites or an irregular quadrilateral, a lot of the time, the trick is just to split it into two smaller triangles. Now, these two triangles that I have just split this into are symmetrical. They are congruent because, this is not a proof of congruency question, but take my word for it. They're two identical triangles. Obviously, one's been reflected, but the important part is both areas are the same. Okay, so what I need to do now is work out the area of one of these two triangles and just double the answer. So the way I'm going to do it is by using the formula for the area of a triangle using sine. So it's a half, almost similar to like the area of a normal triangle. So a half of BC, your two lengths, times the sine of the angle between. That's the only difference. Usually you do half base times height. Here we do half of B times C. But because it's not 90 degrees, we do need to do sine A as well. So it doesn't really matter which one's B and C because doesn't really matter. Let's go with 6 and 11. You'll realize obviously 11 times 6 gives you the same thing, hence why it doesn't matter. sine 118. Now this will give you the size of, or the area of one of the triangles. So 0.5 times 6 times 11 times sine of 118. It's going to give me 29.137 dot dot dot. But obviously the area of the kite will be two lots of this, because as I said earlier, these two triangles are symmetrical and they are the same area. I mean, you could use the formula again if you don't believe me, but it's a bit of a waste of time because the answer is 58.27454,113, which to 3SF rounds to 58.3 centimeters squared. Always remember your units, but in the answer line, they've kind of told you it anyway. Let me confirm this with the mark scheme, and I am interesting. The mark scheme says what this is my handwriting being terrible here. 58. I can't believe my handwriting here is terrible, isn't it? You don't need to tell me that. I know. 58.3. Christ. God. Right, number 17. Okay. We gotta do some shelving. Okay. The Jeffrey Bezos special. So, two kinds of shelves. R and S. You've got a sequence of patterns. So here are the first three terms. Okay, right. So basically, yeah, the smallest possible shelf it always starts with an R and it always ends with an R. And obviously, for every S, there's a gap in the middle. Okay. So let's think about this. Could we make a formula that describes the number of R's? Okay. Now, so we notice here you've got for 2R's you've got 1S. This shelf here you've got for 3R you've got 2S. And for this one at the bottom you've got 4R, you've got 3S. There's always one less S than there is in R's, right? Depending on how big or small you build your shelves. So work out the width of a 6R shelves. So it will be, to build 6 R's, you'd have to do 6 R's, and obviously in between the gaps you'd need 5 S's. So what is it? 6 lots of 2.4 plus 5 lots of 3.5. Simple calculator work, really. 6 times 2.4 plus 5 times 3.5. I'm getting 31.9. Can I get a 31.9? Absolutely. A shelving unit has NR type shelves. The total width is W. So let's think about what we did earlier, right? We did however many R's there are. So all we're doing here really is, instead of saying 6 like we did earlier, we're now going for the general approach of just saying N type of R. So the total width will be N multiplied by R plus, because there's always one less, in brackets, do N take away 1 S, right? So, for example, if N is 6, like in part A, the number in front of S would be 6 take away 1. It would be 5. Fair enough. So now, all we've got to do is make this equal to W. So W equals, the total width is N capital R plus, in brackets, N minus 1 S. I don't think you need to expand that. Or do we? Hang on a minute. In terms of N, okay. So we know how big we do know how big these shelves are, don't we? So we know R is 2.4, so it'll be N lots of 2.4 plus N minus 1 lots of 3.5. Right, this question isn't a general formula. Well, it is, just wants width of the total shelf. So we've got 2.4 lots of N plus, expand your bracket, 3.5 lots of N, take away 3.5. Collect your n's together, your 2.4 and 3.5, that's what, 5.9 n? Take away 3.5. We're good. Brilliant. Number 18. Caden and Sonia. So is it Sonia or Sonja? I don't know. But they're going on two car journeys. All right, I'm here for the ride. For Caden, she's got a distance of 80, and it's not accurate. It's been rounded to the nearest 5 kilometers. So already I'm thinking, well, that could mean that her total distance could be, you always halve what you're rounding to. So halve it, which is 2.5, and then you add and subtract from 80. So the lower bound would be 77.5, and the upper bound would be 82.5, right? Because you always halve and add and subtract either side of the rounded value. Cool. So that's my upper lower bound. And 1dp, again, half of 1dp. So one decimal place, 0.1, halve that, which would be 0.05, and then subtract that to 2.7. So time would be 2.7 take away 0.05 would be 2.65. And obviously add 0.05 would be 2.75. Okay, we're cooking. And Sonia, again, I'm not going to go into too much detail here. Same idea, really. So 2SF, so we're talking ones here. So half one is 0.5, so the lower bound would be 32.5 and 33.5. And the nearest 0.1 hour, half that would be 0.05, so a time will be 0.95 hours and 1.05 hours. So all my distances and times were either in kilometers or hours. Okay, so Caden says my average speed could have been bigger than Sonia's. Well, right, let's consider the upper bound for Sonia. So what is the fastest Sonia could have been versus the lower bound? So what's the slowest that... I misread that again. I'm having a shocker right now. So actually, because of the way they phrased it, it's a bit of an English issue on my part, my bad. I want the upper bound for Caden, because it is spoken through the voice of Caden. And she wants to know, is she faster than Sonia? So what's Sonia's slowest possible speed? Let's think about in terms of worst case scenario for Caden. Or best case rather, right? Because she's saying, I could have been faster. So let's give her the benefit of the doubt, right? Let's look at her best case scenario versus Sonia's worst case scenario. So for Caden, as far as speed goes, what's the fastest possible speed? Well, the upper bound, we want to do the upper bound for speed, distance, which would have been 82.5 divided by, we want the answer to be as big as possible, so choose the lower bound for your time. So it will be 82.5 divided by 2.65, and this will give her the best possible chance of beating it. Similar for Sonia, so we want the smallest possible speed for the smallest possible distance, 32.5, 01.05. Let's do a bit of calculator work now and work out, right, Caden, on a good day, basically, would have got and we'll express as a decimal here because we are comparing 31.13207.547 versus Sonia, who is getting 30.95238.095. So yes, Caden is correct. Correctamundo. Let me just have a look at the mark scheme. I'm pretty confident the same values would have been shown. This mark scheme's not. They've got some funky units of speed here. Not really sure why they've gone with this. They've got meters per hour, kilometers per minute. What the hell? I'm a bit baffled. Why? I mean, I'll post the mark scheme's very confusing. Yeah. Oh, here we go. In the footnotes, the way they worked it out is very confusing. The mark scheme because they got some weird. They've assumed they've assumed most students have worked out meters per hour, which would be way more work than is needed, or kilometers per minute. This is craziness. Kilometers per hour is by far the easiest way to compare these. And in the footnotes, it has these two numbers. So yeah, we're all right, Caden, and the values are correct. Cool. 19 parallelogram. We got an acute parallelogram. Okay. Okay. Now, like the kite question, by drawing a diagonal, um, you do actually split the top triangle and the bottom triangle are identical. Again, proof of congruency if you don't believe me. Well, actually, it's an SSS triangle, isn't it? All three lengths are the same. So this is an easy proof. It's not the question, but trust me when I say they're identical. So if the area of the parallelogram is 18, each triangle has to be 9. So why am I doing this, you ask? Because we can do another area of a triangle using sine. So we can say area 9 is half of BC sine A. And this time I don't know what A is, right? So let's call that A. So 9 equals 1 half 3.8 times 6.1 times cosine of A. So a little bit of magic here. So what I'll end up doing is I'll times out your 0.5, your 3.8, and your 6.1. I'm getting 11.59. Just double checking my calculator screen. Yeah, 11.59 seems to be it. Cos A is 9. So A, you know what, let's not take any shortcuts. Cos A is 9 over 11.59. And to work out the angle A, you'd have to do the inverse cosine. I can't believe I've written cos. What's going on with me? It's sine A, isn't it? Sine A, sine A. It's been a long weekend. Sine inverse of 9, 11.59. And let's do that. Shift. Sine 9 over 11.59. And I'm getting an angle of 50.94 degrees. 944.090005 degrees. So with that in mind, now I can just work out the length SQ or QS by using that angle and using the cosine rule. That's why I mixed it up. In my head, I was already thinking the cosine rule. So remember, the cosine rule is, and you are given this in the formula sheet, a squared is b squared plus c squared minus 2bc cos a. So the a is fine. The a is the thing we're actually trying to find. It's this length here. So a squared, let's call that b, let's call that c. 3.8 squared plus 6.1 squared minus 2 lots of 3.8 times 6.1 times cosine of 50.94. I'm going to use the value in my calculator, so it'll be way more accurate. Okay, let's do this. So 3.8 squared plus 6.1 squared minus 2 times 3.8 times 6.1 times cos of my previous answer, 50.944, gives me, and be careful here because this is a squared, 22.4395, dot, dot, dot. You want to square root that? which makes your answer the A, or length QS, 4.737. So it's 3SF 4.74. Let me just get a VAR check on my mark scheme. 4.74 indeed. Right, we're nearing the end now. We're in sort of the final stretch. Number 20. Okay. Okay. So let's start by just sketching out. I want to sort of visualize what's going on here. So it doesn't have to be accurate, but 4.7 would be what, roughly there. That's the center of your circle, and you're told that 6.11 up here is a point A on the circle has coordinates 6.11 and AOP, which would be down here somewhere. So imagine this is O, this is A, and then you've got AOP forms a diameter. So if you're picturing your circle, it's going to look something roughly speaking like that. This is probably a poor diagram, to be honest, but what do I know? Well, if it's a diameter, it has to follow a straight line path. So if you're sort of from this point to this point going from 6 to 4, the next, you'd have to go 2 left again. So this coordinate would actually be, take away 2 from 4 is 2. And likewise for your y coordinates, if it goes down by 11 to 7, which is what, taking away 4 every time, this one would have to be 3. So we can start by deducing that P is the coordinate 2, 3. Now, to make my life a little bit easier, in light of the fact that P is a positive pair of coordinates, it might be wise to do a better sketch. So, yeah, you've got your P, you've got your 2, 3, you've got your 4, 7, which is O, and then you've got your A, which we said was 6, 11. This is a much better sketch if I don't mind saying so myself. It doesn't have to be. You don't even need a sketch, to be honest, but helps me kind of wrap my head around what the question's asking me. So we started by finding point P. It wants an equation to the tangent at P. At P. Well, let us. This blue line. What is the gradient? Well, the gradient M is always y1 minus y2. So basically take away your y coordinates. Any pair of y coordinates will do actually. And then you've got x1 minus x2. So always remember, whatever coordinate you pick from first has to be the same x coordinate that goes first on the bottom. Same for the y. So it doesn't actually matter which pair we choose. Don't choose all 3, we only need 2. I'm going to go with A and P, why not? You should get the same gradient no matter what 2 pairs of coordinates you get. So look, I'm going to do 11 take away 3, followed by 6 take away 2. Simplify this, 8 divided by 4, or 2. That's a nice gradient, isn't it? M is 2. Now, a tangent, you need we call this the normal. Normal meaning it's sort of perpendicular. So the gradient of the tangent, they always have this property, right? So if I sketch the tangent, I'll do this with pink. The tangent at P is going to have, these 2 lines they always meet at 90 degrees, right? A diameter and a tangent meet at 90 degrees and all that good stuff. So remember, you've got M. So if I say this was my earlier gradient, M times, and if it's perpendicular, M perpendicular, they always, any 2 lines that are perpendicular, their gradient's always multiplied to -1. So we can say that 2 times my perpendicular value M, which is the perpendicular gradient, is -1. Hence, the gradient I want, the gradient of the tangent, is -1/2, right? both gradients, this one and this one, have to times square minus 1. So now it asks for the equation of the tangent, right? And we'll do it in the form y equals mx plus c. Any straight line, y equals mx plus c is the way. So this line, what do we know about it? We know the gradient, we know m is minus a half, and we also know that it crosses this point here at 2, 3. So the last thing to do now is really just to find the letter c, and we can do that by substituting in x, y into my equation. So 3 equals minus a half times x2 plus c. This is going to give me 3 equals negative 1 plus c. C is 4. So the equation of the tangent at P, beg your pardon, is y equals minus a half x plus 4. Let me get a var check. These are nice numbers. I'm feeling good about this one. Yeah, they've got that. They do, in the formula sheet, they'll have the y minus y1 equals m bracket x minus x1. Some schools teach that method, but I'm happy with this one. That would be full mark there. 21, we've got a histogram. Okay. So in this histogram, there's nothing to the left of 200, nothing to the right of 800. That's what they mean by the first line. So we've acknowledged that. The number of trees for which are between 3 and 400 is 8 fewer number of trees between 4 and 500. Okay. Right, so the number of trees for which between 3 and 400, so this rectangle here, is 8 fewer than the number of trees for which are 4 and 500. So here and here. Oh, this is a bit of a nasty one. So let's say that each little square is x, because I don't know what the scaling is. Okay, bear with me. So this one would be 15x, making that the area of the first rectangle. We'll get to this bit in a minute. So between 3 and 400, you do 100 lots of, well, the height of the rectangle will be 15x. Right, that's the area of this one. And that is 8 fewer than the height between 4 and 500. All right, so the 4, 500 bit, there's 2 rectangles here. So this one's got 20. Oh, this is a killer. 10, 20, 30. This. This rectangle on the left, annoyingly, is 37.5 times 50x. 37.5x, which is the height here, times by 50. Oh my word. So 37.5x times 50. And obviously this bit of the rectangle on the bottom, and again it's another nasty one, is 12.5x times by 50. Now to make matters worse, it's saying that this first blue rectangle is 8 fewer. So they're almost equal, but in order for it to be equal, you'd have to take away 8 from the purple at the end. So let's solve this now. It's going to require a bit of calculator magic. So we've got 1500x on the left equals, I'm going to just add all of that in one go. So you've got 37.5 times 50 plus 12.5 times 50. That's 2500x. Take away 8. Okay, so move the 8 to the left, bring your 1500 to the right. So A equals 1000x. So, wow, this is some nasty numbers here. X, the value of every little square, is going to be, and I can't believe this because I've never seen these numbers before. 1, it's going to be 0.008x. Wow. Okay. So, I mean, to make our life a little easier, I suppose, you say 10x. So every 10 little boxes, it'll be 0.08. So the scaling is very odd. But it's not, I don't know, it could be worse. But basically every 10 squares on your y-axis is going to be represented by 0.08. 0.08. So this would be 0.16, 0.24, 0.32. Yeah, the scaling is very difficult. So again, I'm going to rub this out to give myself more space. If you want to read it again, just rewind. Work out an estimate for the number of trees in this part of the forest that have a height of greater than 500. Okay, so let's work out the area of both the blue and purple, right? Because that's greater than 500. Starting with the blue one. The width is 100. The height, now if you remember earlier, every little square is 0.008. So there's 13 of them. So actually, do you know what? It might be easier just to remember that every little square is 0.008, and there's 13 in the height. So the height will be 13 lots of 0.008. But that's your height because of the scaling. Multiplied by 100. Now I'm getting 10.4. It's an estimate, doesn't have to be a whole number. And the purple one, again, the height is, the width is 200 here. And the height is 3 lots of 0.08. Because of the scaling of my x-axis. So you've got 3 lots of 0.008 times 200. And you get 4.8. I will write my working down. 3 lots. So all that's left of me to do now is to add these two numbers, 10.4 plus 4.8. They're not nice numbers, so I'm a bit worried about this one, but I'll check the answers anyway. The number of trees, 10.4 plus 4.8 is going to be 15.2 trees. Why have I got a feeling that's wrong? Just not nice numbers. Let me check. Now, in the mark scheme, it is saying, let's get my head around this. So the good news is they also agree that 100 small squares represents 8 trees, which is in line with me saying that 1 square is 8/100ths of a tree. 8/100ths. Okay, so the scaling's right. I have spotted my mistake, and it is a small one, and very annoying one at that. If you zoom in really closely, it's not 13, it's actually 12.5 in height. So let me go back. The fix is a easy one, but it's that, isn't it? So annoyingly, I should not have said 13. I should have said 12.5. Yeah, I hate questions like this because they're not really testing my knowledge on histograms. My knowledge is this is more like a eyesight test. So this now is 10 is the height of my first rectangle, and which is in line with what the mark scheme is saying. Secondly, I've done the same thing on the second one. The height here is 2.5 and not 3. So please forgive me for my terrible eyesight. I'll wear not sunglasses. But I will wear glasses next time. Yeah. I mean, I'm still walking away with a lot of marks here, but silly ones I've dropped, which, hang on a minute. Sorry. That was not where I needed, it was there I would need to change it, wasn't it? 2.5 lots of 0.08, which is 0.02, times that by 100, times it by 200 also. No, wait, no. I don't know what I'm doing in the second part here. So the width of the rectangle is, well, the height is 2.5 lots of 0.008, which we said was 0.02, sorry, times by 200, which gives you 4. So the area here is 4. The number of trees is not what I said earlier. It's 10 plus 4, 14. So 14 trees is the correct answer. That was a nightmare of a question. I just don't like how they did half squares. I think a lot of people like me would have lost marks there just because of how tiny them boxes are, especially on the iPad. Right, we've got 2 similar metal statues. Statue is the bigger one. Surface area K is... Okay, that's actually not that bad. So we got to do volume. So we'll say that B is 20% less than A. So we'll say that B is 0.8 times whatever A is volume-wise, right? When it comes to volume, B is 0.8 lots of A. Now, actually a better way of writing this, because I want the examiner to be crystal clear about what you're expressing, is you want to say the volume of A equals 0. B is 20% less. So the volume of B equals 0.8 the volume of A. Okay, so in order to sort of work out, so we say, yeah, the number you'd multiply A by is 0.8. Okay, so this is what we call the volume scale factor, is 0.8. Now, the linear scale factor is always the cube root of the volume scale factor. So basically, if we were given the height and width of A and B, the relationship between those heights is B would be, let's work this out, the cube root, 0.8 is 0.92831, ... Basically, this means that all the lengths of B would be 92% of A, right? So roughly what, like 7 point something smaller. But this is about surface area, so we need to work with this. The area scale factor is the linear scale factor squared. So we're going to square 0.92831, and we are going to get a number of, so the area scale factor is 0.8617773876, ... this means that shape B is 86% of shape A, right? Roughly speaking. The surface area is K less. So if it's only 86%, so you could say that B's surface area is 86.17% of A's. So it wants, how much less is that? Well, it is K equals 100%, take away that number, 86.17, which would be about 13.82. So it's 13.8226124%. So rounding it to 3SF would be 13.8. Right, that would be the answer. Let me get a bar check. 13.8 is correct, and that's it.